Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus. I will present the results of our research with this title. Introduction. The advancement of technology in the current era has led to the development of various software applications. Software must be undergo quality testing before its use. One method of software testing is through defect level evaluation. An accurate classification model is needed to determine whether the software contains defect or not. Hyperparameter tuning can be improved the accuracy of the gradient boosting model for software defect classification. Problem identification. The first, testing the machine learning model to evaluate its performance in classifying software defect, and then testing the second dataset provided in the previous study, which is the baseline GHPR dataset, and the last, optimizing hyperparameter tuning to assess whether it improves the performance of the previously tested model. And our scope of research testing in conducted using the baseline GHPR software metric dataset, and then testing the dataset with 3 machine learning models: logistic regression, random forest, and gradient boosting. And then optimizing hyperparameter tuning for gradient boosting using Bayesian Optimization or Hyperopt and Optuna. And then analyzing model performance using evaluation metrics such as precision, recall, accuracy, F1 score, and area under curve or AUC. So this research methodology, first of all, we collect the data set. After that, we prepare the data in preprocessing, and then enter to split validation. In this step, we divided the data for data test and data training. After that, we classify the models: logistic regression, random forest, and gradient boosting. In this step, we achieve the best model, and after that, using hyperparameter tuning on Hyperopt and Optuna. So after that, we achieve the best models and optimization between Optuna and Hyperopt. The first step, we collect dataset, and the data collection process for this research conducted using a public software defect dataset accessible from GitHub. And the previous study, 2 dataset models were provided: a SQL database model and a software metrics dataset. This research uses the baseline GHPR or GitHub pull request software metrics dataset. The dataset consists of 6,052 instances with 3,026 defect instances and 3,026 non-defect instances. Next step, pre-processing data. In this step, we removing irrelevant attributes such as the secure hash algorithm attribute. Split the dataset into training and testing sets. The split method divides the data into 60% for training and 40% for evaluation when testing machine learning models. For hyperparameter tuning, the data is divided with 80% for training and 20% for testing. Testing was conducted using cross-validation. And now, in the testing, after that we found the models between models that we use: random forest, logistic regression, and gradient boosting. In this test, gradient boosting achieved the highest accuracy score of 77.86%. In the further testing, subsequent testing was conducted using the gradient boosting ensemble model optimized with two hyperparameter tuning models, Bayesian Optimization or Hyperopt and Optuna. In this test, we split the data training and testing, divided 80 by 20. The result of Hyperopt with the TP algorithm was conducted over 80 trials to find the best hyperparameter combination and optimal parameter values. The testing results show an accuracy improvement of 0.01. Additionally, hyperparameter testing with Optuna used the trial function over 100 trials to find the best parameter values. The testing result show a slight decrease in accuracy by 0.09, and it means Hyperopt achieved the best score for accuracy than Optuna. This is the test result comparison table. Model gradient boosting achieved the best score in accuracy, precision, recall, F1 score, and AUC. Before optimization with Hyperopt and Optuna, the accuracy score for gradient boosting is 0.78, precision 0.78, recall 0.74. After optimizing with Hyperopt, improve to 0.79 for accuracy score. Additionally, optimization with Optuna decrease 0.09 as the result of the test. Gradient boosting has highest score accuracy before optimization, and after using optimization, Hyperopt achieved the score accuracy for gradient boosting become 0.79. And this is a test result comparison graph. We can see in this graph that Hyperopt achieved the best score in accuracy, precision, recall, F1 score, and AUC. So, based on the research result for software defect classification testing on the baseline GHPR dataset using the initial model with 3 machine learning models, logistic regression, random forest, and gradient boosting, the highest performance in the initial testing was achieved using the gradient boosting model with a recall score of 0.74, precision score of 0.78, F1 score of 0.76, accuracy score of 0.77, and AUC of 0.77. Further testing with two hyperparameter tuning optimization models, Bayesian Optimization or Hyperopt and Optuna on gradient boosting revealed that the best performing hyperparameter model was Bayesian Optimization or Hyperopt, with performance result of 79.10% for the accuracy score, recall of 79.70%, precision of 80.1%, F1 score of 75.69%, and AUC of 78.9%. It can be concluded that the hyperparameter tuning model Bayesian Optimization or Hyperopt is capable of improving the accuracy of the gradient boosting model for software defect classification by controlling the training algorithm behavior to parameters, thereby enhancing the performance of the trained model. Thank you for your attention. Hopefully this research can be useful, and further research can continue this research with other models. Wassalamualaikum warahmatullahi wabarakatuh.